Okay, so we have our second practice problem on the back here. So it says a person pushing a stroller from rest, starts from rest, uniformly accelerating at a rate of 0.5 meters per second squared. What is the velocity of the stroller after it has traveled 4.75 meters? So writing out my givens again here. So I have a stroller, it starts from rest, and then it accelerates at this rate. And what is the velocity after it's traveled 4.75 meters? So if I start from rest, if I'm at rest, it means I'm not moving. So I'm at 0 meters per second. And if I'm starting at rest, this keyword start here tells me that this is an initial speed and not a final speed, or in this case, initial velocity and not a final velocity. So my VI is 0 meters per second. From rest, we accelerate at a rate of 0.5 meters per second squared. So I have accelerating the meters per second squared unit. So this number here represents acceleration. What is the velocity of the stroller after it's traveled 4.75 meters? So that meters unit, and we have that little table on the front if we need to reference that, but that meters unit represents my displacement, so how far I went. So d displacement is equal to 4.75 meters. And I'm trying to find the velocity of the stroller after it's moved. So my unknown is velocity. I know how fast I was going at the beginning of the problem. So my unknown this time is my final velocity. So how fast was I going at the end of the problem? So now I have to pick out an equation that has VI, A, and D in it, and it's set up to solve for VF. So I have a couple that say VF equals. This one has VI, A, and T. Now I do not have VI, A, and T in my givens, so I'm not going to choose that one. In fact, I'm missing time here. So I'm going to use this no T formula, the one that does not need time, but it uses initial velocity, acceleration, and displacement because I have those. So the equation is VF squared equals VI squared plus 2AD. So time to sub. So I'm starting off here with VF squared, and I'm looking for VF squared. I have VI, so that's 0 meters per second squared, which in this case will just end up being a 0. If this was a number, then I would have to square whatever number this was. So this would be like 2 squared if my VI was instead 2. Plus 2 times the acceleration, which is 0.500 meters per second squared, times my displacement, 4.75 meters. Now, notice too that this VF has a square next to it. So this is set up to solve VF squared, but I'm looking for VF. So after I multiply all this together, I'm going to square root that number. So I'm going to square root both sides. What I do on one side, I do on the other. So that's going to give me VF equals a big square root. Since this is 0, I can just rewrite this as 2 times 0.500 meters per second squared times 4.75 meters. So multiply all this. We're going to square root that here. And that gives me a final velocity of 2.179, which I can sig fig round up here to 2.18 meters per second. All right, so that's our last practice problem here. So you have in your notes here a now you try problem with work being shown. So give that one a shot. This is a 2.50